our product. Introduction. This is a discrete mathematics project. It embeds steganography with AES to give a super secure data hiding solution. We have made a working prototype in Python. Our product's name is Xtag and we have designed a logo. The team: Sumukh Patel, Akshat Prasad, Naman Modi, Aryan Jivani, and Shekhar Gupta. How Xtag works? Let's understand AES and steganography. Steganography: hiding information in an image. Steganography: steganography originates from two Greek words, stagnos, covered or protected, and graphy, writing. Stagno is a journal method of hiding secret information or data inside any type of digital media like audio, video, images, etc. Steganographic terms: carrier or cover file, a file in which important information is to be hidden. Stagnum medium, a medium like image containing important information of steganography. Embedded or payload, the information which is to be hidden. Stagnolysis, the method of detecting important information inside file. Now this is the steganographic framework which concludes our overall algorithm. Now in the steganographic input algorithm, we give three input: the covered, the embedded file, and the embedded message that we need to hide. Now this algorithm gives us an steganographic message and an image encrypted inside it. In order to read or retrieve the hidden message, we have to apply the reverse steganographic algorithm that gives us the covered and embedded message as the output. Image steganography. This technique is unique of hiding data into an image in such a way that no user can detect. A typical strategy for concealing data in an image file is the least significant bit substitution. Understanding images. Images are formed of tiny little dots called pixels. Each pixel is represented in form of 3 bytes, that is 24 bits. One each for red, one for green, and other for blue. Each bit contains the data of how concentrated a color is. We often call it a 3-channel pixel. More about images. The human eye is unable to distinguish between two colors that differ slightly. We either add 1 or a 0 value to the least significant bit in a byte while doing the steganography. This means that the we change the image in a very little sense. This is an example wherein you can easily see how two different images with just a difference of their last two bits cannot be significantly distinguished by human eye. Encoding the data. Now this is where our algorithm begins. Now first we need to add a text file which has to be encrypted. This message should be represented in an array of ASCII characters. Calculate the required number of pixels, which is equal to 3 times the length of ASCII letter array. Required rows are determined by multiplying the required pixels by image width. Now this is how our algorithm works. Our algorithm takes into 3 pixels at a time and work on it. Having 3 pixels and 3 channels each, we total have 9 8-bit pixels. Now our algorithm alters the least significant bit of each of these 9 array of 8 characters. From bit 0 to bit 7 we have the data bit and an EOF bit, the ninth one. Now our data is embedded in these 8 bits, and the EOF bit helps the program specify if a message is completed or not. If a program encounters an 0 EOF bit, it means the message is not yet complete and the program reads the next in 3 pixels. If it finds or encounters a 1 EOF bit or a high EOF bit, it terminates and displays the message it decrypted. Encoding the data. So we first have to encrypt the data as I explained in the above algorithm. And in order to decrypt the data, we have to apply this algorithm. Now, difference between steganography and cryptography. Steganography ever concealed the presence of communication, while cryptography obscures the content of a secret message with malevolent individuals. When an attacker reads the secret message, the cryptographic system is compromised. In order to defeat a steganographic system, the attacker must recognize it first. Conclusion. Steganographic technique lessen the likelihood that a message will be picked up. Steganography by itself is not a good method of maintaining secrecy, and neither are short block permutation of simple substitution of for encryption. However, when these technologies are coupled, much powerful encryption procedures can be made. AES, Advanced Encryption Standard in Cryptography and Network Security. Introduction. Advanced Encryption Standard is a specification for the encryption of electronic data established by the US Navy Institute of Standard and Technology NIST in 2001. Symmetric key blockchain, that is, same key used for encryption and decryption. AES is widely used today as in much stronger than DES and triple DES despite being harder to implement. AES is implemented in software and hardware throughout the world to encrypt sensitive data. Difference between AES and RSA. RSA is a system which employs asymmetric cryptography. The term asymmetric comes from the fact that there are two related keys used for encryption, a public and a private key. While RSA encrypt works well for protecting the transfer of data across geographic boundaries, it its performance is poor. AES is a system which employs symmetric cryptography. Symmetric encryption involves converting plain text to cryptographic ciphertext using the same key or secret key to encrypt and decrypt it. AES cover the drawbacks of RSA. Features of AES. Security. Competing algorithms were to be judged on their ability to resist attack as compared to other submitted ciphers. Security strength was to be considered the most important factor in competition. Cost. Intended to release on a global, non-executive and royalty-free base, the candidate algorithms were to be evaluated on computational and memory efficiency. Implementation. Factors to be considered include the algorithm's flexibility, sustainability for hardware or software implementation, and overall simplicity. How AES works. AES performs operation on bits of data rather than in bytes of data rather than bits. Since the block size is 1 to 8 bits, the cipher processes 1 to 28 bits or 16 bytes of input data at a time. AES include 3 block ciphers. AES 128 uses a 128 bit, AES 192 uses a 192 bit, and AES 256 uses a 256 bit key length to encrypt and decrypt a block of message with 10, 12, and 14 rounds respectively. Symmetric, also known as secret key cipher, use the same key for encryption and decryption. The sender and receiver must both know and use the same secret key. It's working. A key schedule algorithm is used to calculate all the round keys from the key. So the initial key is used to create many different round keys which will be used in the corresponding round of encryption. The numbers of key created by key expansion is number of round plus 1. Details. Encryption algorithm is based on cipher, whereas decryption is based on inverse cipher. For inverse cipher, round keys are applied to reverse the order. That makes it stronger than DES. Each round except the last one uses 4 transformations. Last round does only 3 transformation as it does not include the mix column transformation. Encryption. AES considers each block as a 16 byte 4 cross 4 bit, which is equals to 128 grid in a column major arrangement as shown below. Each round comprises of 4 steps: sub bytes, shift rows, mix column, add round key. Sub bytes. This step implements the substitution. In this step, each byte is substituted by another byte. Its performance it's performed using a lookup table, also called the S box. This substitution is done in a way that a byte is never substituted by itself and also not substituted by another byte, which is a complement of the current byte. The result of this step is a 16-bit 4x4 matrix like before. The next two step implements the permutation, shift rows. This step is just as it sounds. Each row is shifted a particular number of times. The first row is not shifted, the second row is shifted once to the left, the third row thrice to the left, and fourth row four times to the thrice to the left. A left circular shift is performed in the below given example. Max columns. This step is basically a matrix multiplication. Each column is multiplied with a specific matrix, and thus the position of each byte in the column is changed as a result. A constant matrix is multiplied there. This step is skipped in the last round, as you can see in the given below example. Add round keys. Now the resultant output of the previous stage of XOR add with the corresponding round key. Here the 16-bit is not considered as a grid but as 128 bits of data. After all these round, 128 bits of encrypted data is given back as output. This process is repeated until all the data is encrypted undergoing these processes. This is a flowchart that shows the above explained algorithm in a better way. Decryption. The stage in the rounds can be easily undone as these stages have an opposite to it which were performed reverts the changes. Each 128 blocks goes through the 10, 12 and or 14 round depending on the key size. The stages of each round of decryption is as follow. First, add round key. Second, inverse max column. Third, shift rows. Fourth, inverse sub byte. The decryption process is encryption process done in reverse, so I'll explain the step with notable differences. Inverse column. This is similar to the mixed column step in encryption but differs in the matrix use of carry out the operation as given below. Inverse subtype. Inverse S blocks is used as a lookup table and using which the bytes are substituted during decryption. Now this is the overview of how our total algorithms, all these algorithms would merge up to create our product. So first we are having the message. Through AES encryption we will create an encrypted message and we will hide this encrypted message into our image using steganography, and this image will be now encrypted and can be transferred in place of the original text in a more secure way. In the decryption process, we'll first get the image, we'll process the image, applying the reverse steganography, we'll get the decrypted message inside the image, and after using the AES data decryption, we'll get our final hidden image. So that's it. Thank you. Don't forget to try our code out.